morning, guys. So today I am going to discuss an important topic for physics students, and the name of the topic is electric charges and fields. So this topic is basically useful for undergraduate students as well as higher secondary students. So let's see the outlines of my talk. So we'll discuss what is an electric surge, then we'll go to discuss the Coulomb's law and permittivity of a material, and finally we'll discuss the electric field and field lines. Now, what is an electric surge? The electric surge is something possessed by the material object that makes it possible for them to exert electric forces and to respond to electric forces. Now let's take some daily life examples. Many of us have the experience of seeing a spark or hearing a crackle when we take off our synthetic shirts or nylon sweaters, particularly in dry weather. Sometimes we feel the sensation of an electric shock while opening the door of our car or by holding the iron bar of a bus after sliding from our seat. The reason for these experiences is the surge of electric charges through our body, which were accumulated due to rubbing of insulating surfaces. And one most common example of electric discharge is lighting during the thunderstorm. So this is the basic idea of electric surge phenomena. Now let's see what are the different kind of charges are present. So there are two kind of charges, one is positive and one is negative. To understand this concept, let's take an experiment. Suppose you consider a glass rod, okay, and consider a piece of silk. Now if you rub the glass rod with the silk, then if you consider another glass rod which is also rubbed with the silk and bring them together, then they will repel each other. Now you consider a rod that is called even rod, and if you bring rub with the silk, okay, and if you consider another even rod which is bring together, they will again repel each other. But from the figure C, it's clear that if you bring the rub glass rod and even rod together, they will attract each other. So from this experiment we can say that there are two types of charges, one is positive and one is negative. Now the concept is that like charges always repel and unlike charges always attract. That means the positive will always repel each other, and positive and negative will attract each other. Okay. Now let's see and discuss the properties of electric charges. The first property of electric charge is quantization of electric charge. So quantization means suppose there is a system and the total charge of the system is always an integer multiple of a basic charge. Basic charge means charge of an electron or a proton, and total charge can be like 7 times E, 8 times E, minus 8 times E, or 5 times E. That is an integer multiple of a basic charge. It cannot be like 1.2 into E, 1.3 into E. Okay, a fractional number of basic charge is not possible. It has to be an integer number of a basic charge. So that is known as the quantization of electric charge. Now next property is additivity of charge. Suppose there are a large number of particles are present, charge particles present in a system, then what will be the total charge of the system? The total charge of the system is always you have to add all the charges together, and that will give you the total charge of the system. That is called additivity of charge. Now last property is conservation of charge. That means charge cannot be created or destroyed, but it can transfer from one body to another body, and total charges always remain constant. Let's take an example that is already we discussed in the previous slide, that if you rub the glass with the silk, that means glass rod gets the positive charge. So how it gets the positive charge? It will transfer some electrons to the silk. So deficiency of electrons gives them the positive charge, okay, because electrons are negatively charged particle. That means if glass rod transfer 5 electrons, silk will get the 5 electrons. Okay, so only you can transfer the charge, it cannot generate the new charge. Okay, so that is called the conservation of charge. Now next, Coulomb's law. So Coulomb's law tells us that the force of attraction between two point charged particle is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. So these things will be clear if you look at the mathematical expression. So here you can see there are two charged particles q1 and q2, and they are separated by a distance r. Now f is proportional to q1 q2 and inverse proportional r square. So here F equal to k q1 q2 by r square. So k is the proportionality constant, and that constant is called the electrostatic force constant. Now k can be written as 1 by 4 pi epsilon naught, and the value of the k in terms of SI unit can be written as 9 into 10 to the power 9 Newton meter square per Coulomb square. Now what is epsilon naught? So epsilon naught is the absolute electric permittivity of the free space. If you want to calculate the SI unit of epsilon naught, then you have to use the equation 3, and you have to put the units of other quantities like force, surge and distance. After substituting all the units of these quantities, then you will get the SI unit of epsilon naught. And similarly also you can determine the dimension of epsilon naught by putting the dimension of the other quantities. Okay, now electric field. So electric field permits the space around a surge in which the electricity force of attraction and repulsion due to surge can be experienced by any other surge. So what does it mean actually? You can see the figure A. Here is a positive surge, bigger positive surge is there. If I bring a test surge q naught towards the positive surge, then the test surge will feel some kind of force. As both are positive surge, so this bigger positive surge always try to repel the q naught, and the direction of force is along the right. Okay, you can see from the figure. And similarly, if I bring the test surge q naught towards the negative surge, then the negative surge will always try to attract the q naught, and the direction of force is along negative direction. It is clear from the figure. So why actually this test surge is feeling some kind of force? It is because the bigger positive and negative charge are creating some kind of field surrounding it, and that is called the electric field. And if the testers goes in that region, then it feels some kind of electric force. Now electric field lines. So electric field lines are basically the pictorial representation of electric field of a surge. Okay, now from the figure 1b, it's clear that this is the electric field lines, curved line. Now if you consider any point of this line, and if you draw a tangent, that tangent will give you the direction of the electric field. And see the point P here, you can see if I draw a tangent, that will give you the direction of electric field P. And similarly, if you consider the point Q, if I draw a tangent, that will give you the direction of the electric field at point Q. Now electric fields are always originated from the positive charge. That means the direction of the electric field is always outward from the positive charge, and direction of the negative charge is always inward. Okay, so that means electric field lines are originated from positive charge and terminate at negative charge. Now in figure 1b, you can see we consider one positive and negative charge. Electric field lines are coming out from the positive charge and terminate at the negative charge. Okay, you can see this is from the figure. And now if you consider the figure 1b, then we consider two positive charge. Okay, so in this figure, you can see the electric field lines are going away from the positive charge. But one important property you can observe from the figures, that two electric field lines can never intersect each other. It's because if they intersect, then if you draw some tangent, you will get two electric field direction, which is not possible experimentally. Okay, so that's all about the electric charge and electric field, and I hope that you have understood it clearly. Thank you.